So first thing we need to do is decide that this cannot be factored, and in this example, it actually can't be. There are not two numbers that exist that if we multiplied them, we'd get 16, but if we add them, we'd get negative 14. There's no whole numbers to do this. So this is a good example of when we would actually need a different method. Okay, so we're going to abandon all hope of trying to solve this for 0. It's not going to happen. There's no way for us to do this. And we're going to go ahead and move the 16 to the other side. And we're going to try to rebuild this quadratic to be something that we can factor. So the 16's cancel. And we now have x squared minus 14x equals negative 16. Now, the next step is where we're supposed to find that magic number that we can add to both sides of this that turns it into something that we want to factor. And to do that, if you look back in the steps we did before, this is step 2, we're going to divide b by 2, then square it. So, first of all, in this example, which number is b? Negative 14. So, off to the side here, I'm going to go ahead and take my negative 14. I'm going to cut it in half, and what does that give me? Negative 7. Good. Now I'm going to take that negative 7 and square it. What's negative 7 times itself? 49, and it's a positive 49, which is going to be very helpful in a moment. So it gives me a positive 49. We need this to be a positive number, because if it was a negative number, I'd end up with a negative number here at the end. Can you take the square root of a negative number? No. So we want a whole number. We want a positive whole number here. When we get that, we're going to add it to both sides. So this is going to become x squared minus 14x plus 49 on the left equals negative 16 plus 49 on the right. Now we're allowed to do this because in an equation, you can do whatever you want as long as it's the exact same thing on both sides. I could multiply the whole left side by 5 as long as I do the same thing on the right. I can add a 49 to the left out of nowhere as long as I do that to the right. So here's what we've got. On the right-hand side, things are pretty simple. Negative 16 plus 49 is going to give me what? 33. Okay, now on the left, we're supposed to factor this. Now, I'm going to tell you ahead of time here that you do not need to always set up the x method to factor this. You'll be doing that for everything we do today because it's very simple, quick, and easy to do. But we will eventually develop a good shortcut for this. Some of you may already see what the shortcut is going to be. We'll give it a try anyway. We're going to factor this. I want two numbers that if I multiply them, I get, positive 49. But if I add them, I get negative 14. Now, remember, they have to be the exact same number. That's the whole idea of completing the square. We're trying to make something squared. And Renee just said we have negative 7s. Negative times negative would make a positive 49, but if I added them together, I'd get negative 14. So that means that I now have x minus 7 squared, because it's the same thing on both sides, equals 33. So here's the part where we take the square root because we're ready to start solving things. We did all this work to set this up. Let's start actually solving it. We'll do square root to cancel the exponent. Square root cancels squared. So I have x minus 7 equals. Here's where things get real weird. 33 does not have a whole number square root. We know that it's somewhere between 5 and 6 because the square root of 25 is 5 and 36 is 6. So it's somewhere between 5 and 6, but we don't want to just round it off. We don't want to be inaccurate. So we're not going to actually calculate anything here. We're going to say the square root of 33 will be represented simply as the square root of 33. We're not going to change it. But we do know something about this. Every square root has how many solutions? How many answers are there to a square root problem? There's 2, right? Positive and negative. So here's what we are going to do. We're going to say the square root of 33 is not a number that we can calculate, but we do know that it's positive or negative. So that's the only thing we've done. So now, instead of splitting this into 2 separate problems and trying to add things together, we're going to say this can't be calculated anyway. But I do still need to know what x equals, right? That's the ultimate goal here. So I'm going to add 7 to both sides and get that x equals, and here's something that a lot of people have not seen before, whole numbers, like 7, rational numbers that aren't inside of square roots cannot be combined with numbers that are inside of square roots, which means we don't actually have to do any arithmetic here. We just say that this is positive 7 plus or minus the square root of 33. So we're not actually going to calculate some weird decimal. So if we get to the end and we find that this number does not have a square root, we're just going to move the negative 7 that was on the left over and just write plus or minus that square root. Technically, that saves you the last step of splitting things in half. I think it's kind of just about the same amount of work anyway.